Hello everyone, and welcome to the part 2 of the statistics tutorial, where we'll discuss hypothesis testing. Remember, question 1 that Amy wants to answer as part of her statistical analysis is there a difference between the two groups? We had employees that took 100 hours of statistical training, and the control group, another set of employees, another group that did no statistical training. So before we can measure the difference and do all claims about that, the baseline check is there a difference at all? Because maybe there is no difference. We saw there is variability in both data, and perhaps the difference we observed is due to chance. So this detailed procedure to compare, to show that there is a difference between two groups is called hypothesis testing. And we want to make a clean-cut decision. Yes, there is a difference between these two groups. That's a prerequisite for any other statistical analysis. First, make sure that the data is not due to chance. Okay? Why? I mean, it's a little weird procedure. You'll see there's a lot of steps, but it's a standardized and well-accepted way to make these claims. You know, there is a difference between these two groups. The notion of statistical significance, all the science papers use this approach. It's a little outdated and old, but it's still the standard. So okay, so let's see the setup. What we're gonna do in order to say, is there a difference between the two groups or there is no difference? You know, we formulate the two parts, the two alternative realities. The null hypothesis, which is a null meaning zero, as in no difference. So we want to show that there is a difference, but instead what we're going to work with is that there is no difference, do some analysis, and then show, well, under the null hypothesis, the observed data is very unlikely, so must be the opposite of the null, which is the alternative. Okay, so the null hypothesis says there is no difference between the two groups. Whatever employee lifetime value for, if you take statistics course or if you don't take statistics course, there is no difference. The exact value, we don't care. We just know it's some, we just call it some mu naught. We don't care. And so under the null hypothesis, the model for both distributions, for statistics employees who did statistics, employee who didn't do, is the same. The alternative, what we really believe when we want to show, is that there is some effect. So the mean from the people who did statistics and the mean who didn't do statistics is different. Hopefully this is greater than this, but we'll do that later on. We'll do the estimation. For now, we just want to reject the one in red. Okay? Specifically, what do we mean reject? It means that we observe a difference of 130 from the sample when we computed the difference between the mean, the group means. And we want to show that this value is unlikely to have occurred under the null model. So it's unlikely to take, if there is no difference and you take a sample of 31 people and a sample of 30 people, compute the mean in each group, subtract, the chances of observing 130 is very unlikely. How unlikely? In fact, we're going to compute a number called the p-value. So if the p-value is really, really small, less than 5%, we say we can reject the null hypothesis. If it's not smaller than 5%, then we say we cannot reject. We fail to reject the null hypothesis. Okay, so we'll talk about that in a second, but this is the setup. This is, in fact, this box here is the most important one. We assume that both the people, the statistics people and non-statistics people have the same mean and possibly different variances. We'll see about that later. Okay. The hypothesis testing, null hypothesis testing, is a fairly complicated procedure. This is even a simplification, so in the book we'll go into even more details. So we'll talk about the details in just about a second, but before I do so, I want to, at a high level, what are the inputs, what are the outputs? If it's a procedure, it has inputs, has outputs. So the inputs, remember from the data notebook, we computed the means within each group and the standard deviations and the variances within each group. So that's only data we need to extract from the sample. And the output will be a decision, reject the null or fail to reject the null. So inside the hypothesis testing, there'll be a lot of intermediate computations, analysis, simulations. We'll see a lot of details, but at a high level, that's what we're doing. We want to take some sample statistics and then reach the output is the final conclusion. Okay, let's look at this a little bit more detail. We said how we start with the yes/no question. Is there a difference, or there is no difference? That's the yes/no question. The procedure we're going to use, hypothesis testing, will allow us to justify our conclusion. So that's why we're doing that. It's a standardized procedure. The null hypothesis, remember, is no difference. The alternative is there is a difference. Focusing on the null hypothesis, we need a model for the data. So how does, under the null hypothesis, what are the data we are likely to observe? We're not just going to invent it. Remember the null hypothesis. We're going to choose a model that has the same variability as the sample we have observed. So that's why we measured the variance of within the two groups. We're going to need that. Then under the null model, there are two ways, we're going to talk that in about a second, to obtain the sampling distribution for the difference between group means. So what, under the null hypothesis, what kind of differences between group means are we likely to observe? So we'll get a distribution for that. And in parallel from the sample, we're going to compute the observed difference. And that's what that's why we're doing all of this, is to compare where does this particular observed value of D fit within the sampling distribution under the null hypothesis. So that's what the p-value is. How likely is this D under the distribution under the null hypothesis? And if it's less than 5%, so very unlikely for this data to have occurred under the null, we say reject. This is false, or this is unlikely. What that means is the alternative is worth pursuing and studying further. Doesn't mean we've proved the alternative. In fact, we didn't use the alternative anywhere in the calculations, but it just gives us a sanity check has passed that, okay, you can start your statistical analysis. The other option is, if it's more than 5%, this has more than 5% chance occurring here, then we say, well, you know what? The data could have occurred by chance, so we don't proceed. There is no, it doesn't say that the alternative is false, doesn't say anything like that. Okay, in order, the language here is very tricky and very specific. You it's very technical. I don't want to talk about that, but if you click here, you will see the details, what I'm talking about. Instead, let's start with analysis. Okay, remember the employee lifetime value, which we prepared in the data chapter? Well, let's reload it again. We got it right here. If you recall, there were 31 rows of employee lifetime values for employees who took no statistics. They have they're the control group, and then 30 values who took statistics. The sample statistic, the descriptive statistics are 1018 and 1048. right? That's different. And we knew the standard deviation for each group. Okay, so this block of data here is what we need. And the statistic, the estimator we're going to use for all the analysis is the difference of means. We just saw that in the last video, how the difference of means is you compute the mean in one group, compute the mean in the other group, and subtract the two. If you don't remember, this is how you extract the data from, because sample contains both groups. And this is how you extract the data. Okay, so let's run this. The observed value of the statistics is 130. So this is what's going on now. We just did this part. We've observed here 130. Now our question, in order to answer, is how do we find the sampling distribution? So we need to find a way under the null hypothesis to build a model for the sampling distribution of the difference between group means. In fact, we're going to show two different approaches: the permutation test and using analytical approximation. So this is what you normally do in textbooks. This is because we are allowed to use Python here. There's a much simpler, more direct way to do it. But once we have that sampling distribution, okay, no spoilers, once we obtain the sampling distribution under the null hypothesis, we're able, and we know the observed value is 130, we'll be able to compare the two and say how likely or unlikely is this observed value. And remember, if it's unlikely, then we reject the null and we can proceed to say, okay, there is a difference. The null says there is no difference. We reject the null means there is a difference. Then we can proceed to question 2, where we actually measure how big is that difference. All right, next video, continue.